While I've got it all in bits, before I start building it back up again for other stuff, this capacitor's got to be dealt with. That capacitor originally sat next to the motor there. There's no room for it up there, so it has to sit on top of the gearbox, and the preferred method of mounting that is this green cable tie that you get in the kit. Am I really expected to tie that on like that and be happy with that? For no money whatsoever you can get 34mm diameter waste pipe clips. Get these from plumbing shops, do-it-yourself shops. Cut the feet off one of those clips and that will snap nicely over there and mount on that. I've still got to make little brackets to go through that hole and secure to the bottom of the clip, but a plastic clip like that is going to be a much better deal, much tidier and much more protective to that capacitor. If you're just going to tie it down, it's going to rattle around and wear through and all kinds of things. Just certainly not a good deal at all. Better than this anyway. What are they thinking? Have a bit of a think. Put some better stuff in the kit. So that will go up there. I've got a bit of old plastic here, which is an old chopping board. I'll just mill this off, make a couple of little block brackets to go through the side there. Piece of steel tube with holes and threads in the end, and I'll just secure that in with some little dome head socket headed cap screws. So after a lot of fuss, I've made two little brackets to go on either side of this plastic pipe clip. This is a piece of old tent peg actually. That's now got a 3mm thread in each end. That will go in there. And this will screw into that. Okay, those two are already tightened up, so that's a much better deal than it was before. I'm going to wrap a bit of black tape around that to disguise it. You can poke it out because this is tapered. But I'm happier with that than I was with this. Made a small little cardboard template for the electrical switch with all the linkage in place, and a dot marked on the template as to where I want the screw to come down, because the screw does need to come down in a particular place to be able to switch that off. Hold the template in place, just trace a line around the outside of it with the scriber. So that's that whole position taken care of. The scribe lines on the vise, referring back to the drawings and the exact dimensions I drilled these holes to in the bottom of the vise. I start off with one hole, 51mm across, 137mm along, 51mm across. So there's half a chance that those holes are going to be in the right place. Another two holes up here for the wiring grommets. Now on the drawing it does say put one wiring grommet through the top here, which will lead, you know, to the switch or to the power, I can't remember which, and the other main power supply grommet to go into the side. I'm not going to put it in the side because this is going to be dragged around all sorts of benches and shelves and all sorts of things in its future. Putting a plastic grommet on the side, it's going to get broken off. So I'm going to put that in the top of the base plate as well, so that the plastic grommets are all kind of protected by other parts of the structure. It's probably going to need to be a hole drilled through here as well, horizontally, to be able to pass the wire through to get to where the switch is going to go. I'll probably just fiddle that by hand somehow. Luckily the aluminium foil does fit in the slot. Should be all the holes in the base plate now, and because of the complicated way I've made this, it's going to be a bit of a puzzle to put together. I don't really want to take that collet off again, because the position of that shaft is helpful to set up the end float. So I've had to put these 3 pieces together, 4 pieces, and then hammer the key in. It did take a good hammering to get that to go in, so I'm pretty pleased with that, which means the key will be tight in the shaft and it won't wear the shaft out. There's always more key sticks out of a shaft than remains in the groove, and the next heart stopper was would it be a good snug fit into there. I've already tried it once, and yes, it is. That's it's a very nice non-clunky fit there. So that's 1/2 put in. And I'm going to have to get this other half. That's not right. Get this other half put in. And then this over the top. This terminal box needs to go on the end, that's on the top of the motor. I've put some masking tape on and marked it out. 4 holes for screws and a large square hole in the middle. I've made this square hole smaller than it says on the drawing, because my experience with these boxes is that they're just so fragile. Any effort at all, any force on that box in the future on these little tiny screw holes, it's just going to snap and split, and all manner of things. So to try and preserve as much strength as I can in the bottom of the box, I've made that hole a little bit smaller, 40mm square instead of 44. That's going to require some wiggling around of that terminal block to get it in and get it on, but that's no big hassle. Now again, my experience of working with these boxes is that they're so fragile. If you try and saw a hole in the plastic like that, you just end up splitting the whole thing. They're just a disaster. So I've put the lid on it to give it some rigidity, and I'm actually going to fix this in the mill and mill this hole out with a cutter so that I don't split it to pieces. Drill these holes as well, which are extremely close to the side, and I don't even know if there's going to be enough relief on these screws to be able to do that, so I might have to change these for socket head screws. So that's marked out. Just got 2 holes to mark out for the grommets. Again, I'll mill them as well. I'm not going to mess around trying to drill them by hand. These things just break to pieces. Don't often use the wiggler, but I'm not going to edge fine on a plastic box and mess around like that. I'll get this centered up, pick up on one hole, and then just use the table to travel around the 50mm hole pattern. so rarely use it, I've almost forgotten how to use it. The idea of this device here is that point is exactly aligned with the spindle, so that you can bring this down and point it at things really rather accurately. So let's have that as a 0. So that as a 0 as well. A lot of fuss, but do want the holes to be in the right place. These are only 4mm. If they're too misaligned and they bind, then I'll just open them out to 4.5 by hand. But at least the holes are in there now. Get through the plastic without snagging and destroying the whole thing. Yeah, did it. I've got some burrs to deal with, but yep, 12mm holes, that's what we got. The instructions are to chisel away these ribs so that the gland nuts fit. I think I'll be doing any chiseling on a plastic box like this. The Dremel's going to have to come out. Get rid of those ribs so that there's enough clearance for the gland nuts. And I don't believe that there is enough clearance. No, there isn't. There's not enough clearance to get that screw to go down without fouling the side of the box. So these are going to have to be thrown away and use some socket head screws, smaller heads, more expense. I've took all this box off again because on the drawing it tells you to connect the earth terminal to this spare stud here. Well, I don't know why, because there's actually nothing connected to the bottom of this, it's just a blank stud. But there is an earth screw on the motor. So I'm going to make a little jumper lead and bring that up through the terminal box, and we'll have an earth at the motor going right the way back to the plug. This is the motor wire coming in through that gland, P-clip through the rib. I had to drill another hole in the rib, didn't think forward enough. More P-clips, another thin point, and this is where you have to bend the spades over on the switch to stay within the confines of the base. It's pretty poor actually, it's not doing the switch a great deal of good. But this is the amount of wire you got left after doing that. It's nowhere near enough, it's not even a metre, so it'd be alright if you can plug the thing in to an adjacent socket on the wall, but in the shed or the other shed next door, that's not going to be a goer. So I'm going to have to get off and buy about 3 metres of this can never have too much power lead. Well, as you can see, this is all in. What a god awful choice of materials. There's been some effort to shorten the whole affair by putting these 90-degree spades on, but they're just so thick they still can't come below the base of the at the bottom of the base. This switch flops in and out like that because it can't latch on properly because the base is too thick for it. It's like an automotive thing, it's supposed to go in a sheet of plastic. So later on, after I've painted it all, I'm going to have to glue that in, and I will be connecting it in a different way, a better way. Now I'm putting flat spade connectors on here, and they're bare ones, they're not insulated. Gives them a thinner profile, which means I can get more of it on the, you just get a much better electrical connection without all the plastic back shell getting in the way. Now these will be live terminals when the power is plugged in. So these terminals are going to be live, but I've got another plan to deal with that situation. Wouldn't be so irresponsible to leave live electrical connections underneath here, because somebody's going to pick this up one day, put their fingers on there when it's plugged in. It can happen, it will happen. So you need to engineer that away so that it won't happen. Rather, can't happen. So with that you can get a much more solid connection because you don't have all the plastic back shell getting in the way. But having said that, I still need to deal with this switch, which is what this is for. This base plate is so thick that the latches on the bottom of the switch can't grab hold. This is all nicely connected. These connections are a lot more secure than the previous pattern of terminal. Where needed, the flex has been P-clipped up. Runs through that rib anyway, but to deal with the danger of these electrical connections here, the whole thing is going to get a cover on the bottom. It's just a piece of plywood. We are, so nobody can electrocute themselves. Right, so I've got this connected. This is a proper thermal camera and it will show me anything getting unduly hot. Am I pointing at that? There we go. So there you can see a fairly warm pulley because I've had my hands on it, and a fairly cold motor because I haven't had my hands on it. So from time to time I'm going to be looking at these bearings and the motor and everything else to see how hot everything is getting. So this is going to be about 30 minutes as it is, parked up, no load, just keeping an eye on what these bearings are doing. I may stop it from time to time and give it another oil, I haven't quite decided, but about 30 minutes worth of work. So is that powered on? Yes it is. Let's go. Also got a tin of biscuits. Cup of tea. it there and re-oil it. Did a lot of testing yesterday. I was cutting various sizes of different materials, and performance wise in what it can cut, it's better than I expected it to be, but not very happy with the amount of noise that it's making. And where it's coming from is this slide up here. As the blade is pushed backwards and forwards, this frame is rocking backwards and forwards like that as it gets pushed and pulled over the work. And the clattering is coming from these bearing caps here. They're a good snug fit side to side, but there's slack up and down on both bearings, so that is rocking up and down with every stroke, and there's nothing you can do about it because it's the drag on the blade that's causing that. You know, there's only a tiny gap there. It can't be more than 0.2 of a millimetre. But the way these caps are made, you can slide them down and take all of the clearance out, except that with these holes being spot on dimension, there's no room left for any adjustment or compensation on these caps. So I'm going to remove these caps one at a time and just elongate these holes by 1 millimetre each, so that I can get some movement down on the cap, close up that clearance there. So these are the holes I'm going to elongate. There's really, I drilled them 6mm and there's 6mm screws in. They line up with the frame holes, but no movement at all on up and down. So I'm going to put them in the mill, just elongate these holes by 1mm in the proper direction, put them back on with no clearance. Okay, now this is working fairly hard and there's no clatter. Clatter be gone. So, looking at the elapsed time on that, that took about, what we on? About 10 minutes. I think with exhaustion and everything else, that would have taken me more than 10 minutes to cut that off by hand. So I'd call that a result.